I believe it's been about a week since I recorded a video, so if I get a little tongue-tied or tired, don't have the stamina to get through, I'll just blame it on that. Okay. So today we're going to be working with function operations first. And then the bulk of the lesson is going to be composition. This is might be kind of a long video because there's a lot to cover, a lot of different ways that this can look. Now, first up, function operations. I'm going to show you the way that a lot of the math people write it. I'll write it. I guess it'd be f plus g if it was the sum. And the way that we think of it is just going to be f of x plus my g of x. And that's going to just hold true all the way down. So even if I have the difference right here, I am going to subtract g of x. So a lot of people think, well, the x distributes through. Not exactly, but it does look like it in those cases. So f times g of x, let's button them up next to each other. Or they might put a little dot in between it, f times g of x. And then finally the quotient. I'm just going to divide them here. I'm short on room. And we just take our f of x over our g of x. I'm not going to worry with domain on these just yet. That might be a later video. But for now, I just want to be able to find these. Okay? So my first example today, I'm going to give you two functions. And part A, I want you to, looks like do f minus g. So if you remember from the last slide, f minus g, I'm just going to take my f of x function. It's 3x plus 2. And I'm going to subtract off my g of x function. Now you can just subtract right here, or some of you might be more comfortable if you distribute a negative through. That's fine. But look at my use of parentheses on this first line. That's key into getting this to be a positive 25, which is where it should be. I'm going to try to put my answer in descending order. And the only like terms I have to combine are 2 and 25. That gives me 27, which is my answer. So now f times g, instead of putting a minus sign in between it, I'm just going to butt them up next to each other to show that I'm multiplying. Anytime I'm multiplying two, in this case, binomials, a lot of you think of FOILing, or I just think of multiply every term in this binomial by each term in the other binomial. Or some people say distribute twice. And so once I do that, I get 3x squared minus 75x plus 2x squared. Uh-oh, little mistake right there. 3x cubed up front, my bad. And then minus 50. I'd probably accept that, but man, it just looks so much better being in this descending order. So I really like this answer. Let me switch up my functions a little bit. What if my functions don't look alike? How will that simplify? Well, let's go ahead and just write out the f of x. X plus 1. And then plus my g of x, 2x squared. And actually, I'm done right there. Domain gets a little more complicated with this, but since we're not worried about domain today, we're just going to leave our answer like so. I will make a little side note right here. Suppose it says f of g of, just make something after 3. And so what I would do to work this is I would plug in my 3, just like we did in the last unit. So I get square root of 3 plus 1 plus 2 times 3 squared. Well, that's square root of 4, which is just 2. 3 squared is 9 times 2 is 18. So yeah, my answer would just be 20. If it says f of g of 3. If not, if it just says f plus g or f plus g of x, the square root of x plus 1 plus 2x squared would be my answer. So f divided by g, really, it doesn't get simplified a lot. Like I said, when we get to domain, it's going to get a little bit hairier as to what we need to do with it, but that's going to be fine for what we're doing right now. The main event today is going to be composition of functions. Composition of functions. So, on composition of functions, first off, the notation of this. It looks like it says fog right there. It's the multiplication sign not filled in. It's just a little circle. Okay? And so you might see it written like that, or you might see it written as f of g of x. Okay, and that's exactly what I'm saying. I'm saying f of g of x, which is just a shortened version of what is actually going on here. Is f composed, if the composition comes in, composed of g, which is again composed of x. We just say g of x. So some common mistake that a lot of people make on this, they see that f of g, especially people that don't do their homework. Make sure you are doing your homework. Is they think that, oh, well, that's just Mr. Lovelace found a new way to ask me to multiply these two. All right. So don't do this. Don't be that guy that's just going to multiply them. We are doing something different than multiplying. Multiplication might be involved, but a lot of times it's not. Okay. So as for a picture of this, a picture of this would be, let's go back to toast. We talked about throwing bread into a toaster and it gave us toast. That was my rule of the function. Well, suppose that I have that bread. I should put a picture of this down here. I'm going to have to go back and get one. So suppose that I have the bread down here, and let's talk about making French toast. The first thing that happens whenever I make French toast is I have to put it in the batter, right? Or the egg. So it goes through here, and then now I get this really soggy piece of toast. I don't know how I'm going to show it soggy. I'll put little droplets down here. Okay, so I get this really soggy piece. So what happens is it goes through this machine, and this machine could easily be my g function of just going through the batter. Now, to make French toast, I then have to have a skillet. Oh boy. I don't know if my skillet drawing capabilities is up to par. Someone last hour said it looked like a turtle. I don't know. Maybe that's a skillet. And so I throw the bread into the skillet, cook it, and then boom, out pops French toast. Delicious French toast. I love French toast, one of my favorite breakfast foods. And so me throwing it in the skillet right here would be my f function. What I'm looking for on this is I'm looking for a way to bypass the eggs in the skillet and just get away straight to French toast. All right, so it's some machine that I can throw it in. Let's just put a box up here for my machine. I throw it into that machine and it comes out French toast. All right, we're going to take this a step at a time. All right, let's talk about this just with a table first. Actually, first I'm going to give you a formal definition. So you can pause this if you want to read this formal definition. I'm going to talk about it with bread and skillet and batter. Sorry, before we even do a table, I forgot about this example. So the function c of s gives the number of calories burned completing s number of setups. I know when I was young I could do setups really well, but I don't think I can do setups very well now. And so S of t gives the number of setups a person can complete in t minutes. So it wants me to interpret c of s of 3. Realize before I plugged in that 3, I had c of s of t. Okay, so my 3 got plugged in for my t, where t is the number of minutes. So somehow my explanation, I want to talk about something happening in 3 minutes. Okay. Now eventually my rule is going to be work my way backwards. So I'm starting with the t. This is how many setups I could do in 3 minutes. And I can eventually get, however many setups I do, I can get the number of calories burned. So my final answer is going to be this c right here, which is the number of calories burned. So altogether, I'm not really talking about the number of setups I do. Rather, if I just do this activity for 3 minutes in here in the middle, my outcome will be the number of calories burned. So we can just put number of calories burned in 3 minutes. And that would be my interpretation. You might say after doing setups for 3 minutes, the final answer gives me the number of calories that I burned. let's talk about this in a table. Just took a test that had tables on it. Maybe it had graphs on it. I don't remember. But again, my rule with this is start on the inside. Always start on the inside. For instance, I'm going to start with this G of 3 right here. And so the F just comes down to the right. So 3 is my bread. 3 is my input. I'm taking the 3, I'm dipping it in batter. All right, so here's my X column. And this time I have to choose which column is my batter. It says G of 3, so I've got to come all the way over here. And my G of 3 gave me 2. So I dipped the 3 in batter, and it came out as the number 2. Now, I'm ready to throw 2 into the saucepan. So when I take this 2, this is now my new input. So I take the 2, I dip it into the saucepan. I'm just going to use this row, and I'm going to be using my other column. When I dip the 2 into the saucepan, it comes out French toast. This time French toast would be the number 1. Go ahead and pause the video, and you try this G of F of 1. All right, hopefully you got 2 for your answer on that. Another way that we represented functions last unit was with a graph. So I'm going to be given a graph on this one. And again, my rule is start on the inside with this G of 4 right here. So my F is just going to come down for the right. Now again, G of 4, the 4 is my bread, it is my, not input. So I'm going to come over to 4 on my axis right here. Now I have 2 different lines on this one. I'm wanting my G line. My G line is the red one, so I'm going to work my way up right here, and that's where it crossed, at the function value of 3. Just went straight over from there. You got my 3. So now I'm done with that G line. I'm done with the red line. Now I just have a problem like I had on the test where I did F of 3. Except I had 2 graphs over here. So this is now my new input. All right, this is my soggy bread after I dipped it into the batter. Okay, so I'm going to come over here to 3, and I'm going to go up to my F line. My F line in this case is blue. So I come up to the blue line. That's right there at the red line as well. I'm going to go over and get that function value, and it is at 1. So my answer would be 1. Kind of weird. I know a lot of stuff going on. Again, pause the video and you try this G of F of -1. And you should have got -2 on that one. Sorry about the fraction on that. It happens. Should have got -2. Now, whenever we are trying to do this without a graph, without a table, just working with a function, what we're going to do is we're going to first off evaluate the inside function. Still sticking with that inside function first. And then once I get that result, I'm going to plug it into the outside function. No different than what we did on the last 2 examples. Okay. So I'm going to work a couple of these, and then I'll let you work the rest. So I'm just going to start over here with A. It says F of G of 1. Okay. My rule said start with the inside function. So this F part just comes down, and I'm going to do just G of 1. Well, G of 1 means I'm just going to take this 1 and plug it in for that X. So I'm just evaluating that function on the inside. I get F of 0. Okay. So now I'm done with that G part. I just have F of 0. I'm going to take this 0 right here and plug it back into my F function, which gives me 0 squared plus 10, which in turn gives me 10. I think I'll work part B right next to it, since it switches it around. I'm going to erase some of these arrows so I have room to maneuver on this. Again, my inside function is F of 4, meaning I'm going to take 4 and I'm going to plug it in to my X on my F function. So the G comes down to the right, and then my F of 4 is going to be 4 squared plus 10. Well, 4 squared plus 10, that's 16 plus 10. That's right around 26. So now, this 26, g of 26, that's my new input. I'm going to come up here to my g function, because that is what is on the outside, and plug 26 in for the, plug it in for the x. So I have 26 minus 1 on the inside, which just gives me square root of 25, which is 5. I like having numbers in there. I'll go through, pick one of these that you want to work, C, D, or E, work it, and then see if you match my answer. All right, this is at least what I got on C, D, and E. If you have questions on those, put a star by that and be sure to ask me in class. All right, what if they don't give me a number to plug in? Man, it's a little bit more work, I think. This doesn't simplify as much. This is asking me to find f of g. Let's find f of g first. First of all, I don't like that notation, so you're going to see me write it f of g of x. So that way I can just do my substitution up front. Well, this time, I don't have a number to plug in for g of x. So my direct substitution here is just going to be take out this g of x and then put in what it's equal to, 2 minus x. So this works a lot like what we have been doing. We have f of a plus h, and we had to plug it in for f. This time, I'm going to take this 2 minus x, and I'm going to plug that in to this x on my f function. So 2 minus x squared, oops, I meant to leave that blank, squared minus 1. So if I expand this binomial, 2 squared is 4. Multiply the 2 together, negative 2x, and double it. It's negative 4x. And then square the last term, x squared. And so it's putting it in the correct order now. X squared minus 4x. I have a 4 minus 1. That is going to be 3. Okay. Now, a lot of people think working it the other way, doing g of f of x, you should get the same answer. Well, that's where it goes back to multiplication. G times f is the same as f times g, but when you're doing composition of functions, very rarely will you get the same answer. It does happen, though. Again, my first step is a direct substitution. So I'm going to take this x squared plus 1. I'm just going to plug it in. Oops, I did a plus. X squared minus 1. And just do a direct substitution there. Now, I have this x squared minus 1. I'm going to plug it in to my g function. My g function is 2 minus x. So I'm going to do 2 minus whatever I plugged in. In this case, is x squared minus 1. Again, notice my use of parentheses throughout this whole lecture. Right? Anytime I'm plugging something in, I hope I've used parentheses. And so I get 3 minus x squared, or if you say negative x squared plus 3, that is equivalent. Okay. All right, these get a little bit harder. I'm going to change up the function just a little bit. I'm going to let you try both f of g and g of g, and then I'll put all my work up here instead of just the answer. So go ahead and pause the video, give this a go. A little bit of trickery on this one, not too bad because we didn't work it the other way, but those are the answers I got. This g of x, I'm just plugging a function back into itself. Looks kind of weird, but I assure you it does work the same way we've worked the previous problems. All right, to end this marathon list, I think I'm making up for the past week with how long this is. I want to talk about decomposition of functions. Okay? So when we have h of x right here, what it's telling me on this is that my h of x is maybe two functions like f of g of x. And what it wants me to do is it wants me to find my g of x and my f of x. I think it's easier to find the g of x, the inside function first, just to go with our theme on this. And so whenever I look for my g of x, I'm looking for what function did I plug into the other function. It's really easy if you just look at it. First of all, it's not very easy. It's easy if you look at it and the fact that you're just looking inside parentheses. Well, I don't have parentheses on part A. Well, I'm looking inside a square root. Well, I don't have a square root on this one. I'm looking for anything that works as a grouping symbol. In this case, I'm going to be looking at inside my denominator. Okay, that big division sign works as a grouping symbol. So my inside function would just be 1 plus x squared. And then for my outside function, I think of it just asking myself, what am I doing to that 1 plus x squared? Well, for my outside function, it's just 1 over what my previous function was. So my outside function is just that 1 over what my previous function was. And you can definitely check your answer. If I was to plug this blue function into that x down there at the bottom, I do get back to where I started. Let's try this again. The g of x and the f of x. Again, my g of x, this one's kind of trickier because it has that square root of x in it. So I think that square root of x is kind of inside this whole linear function right here. So I think the square root of x would make for a good candidate for my g of x. However, there's 2 of them. And so to remedy that, my f of x is just going to be a matter of throwing in an x in for each one of them. And again, if I check myself and I throw in a square root of x here and here, I'm back to what I started with. It's very abstract. You might have to practice that some. I don't think I assigned very many of them. But good luck with the homework.